Okay, so I'm going to try and go over basically what we went over in class, just a bit differently than he did. So I've got the full assembly here, and I updated my drawing here to be a bit more similar to his. So I'll skip over exactly why certain things are dimensioned certain ways for most of it. Um, Main idea there is that these two circles here, if I can select them, for the diamond pin and the center support, you want you're dimensioning them off of each other or off of this center hole, so you can make sure that they maintain the necessary relationship. So when you go to slide in the part that we're trying to make, it'll actually always fit. Because where exactly along this direction the pin is, or this piece ends up being secured doesn't matter as much as long as you can get it on there. So going back over here, so we have 4 holes here. 2 we figure out the limits and tolerances for ourselves, and 2 that we don't. The 2 that we don't are these counterbore holes here for the nuts that are, or the bolts that are going to hold this in. And that's just because that's not a tooling issue. That's simply just, it's just so it can be secured onto the onto the vise. The other 2 holes we're really worried about are these 2, which I've dimensioned over here. So for the 0.75 tolerance hole, what we're really worried about is, excuse me, we're starting from the nominal diameter on this center support, which is this highlighted face here. And if we look at it, we weren't given any tolerances for this, so we're just taking 0.75 to be the nominal diameter for that plug. And so since it's an interference fit, we go right back to the drawing, and we just take the dimension 0.75, and then we come over to this PDF he gave us, or the sheet, come down to 0.75, which is about here, come over, since we're worried about the hole, it gets plus 0.5 thousandths, 5/10 thousandths. Up here it says that limits are in thousandths of an inch, so that's half a thousandth, and so we apply that to here, meaning it can be, its minimum material condition is 0.7505 and its minimum is 0.7500. The one for the diamond pin is a little bit more complicated, but I think I can explain it a little bit simpler. So originally this was at 0.1880, but I went back into the model and edited this cut extrude one with this new value that I found, or well, found through him and then found for myself again. And so I came over to McMaster-Carr, this is a McMaster part, and I opened up its the drawing they provide, and you see we have it's 3/16 plus either 3/10,000ths and then plus 1/10,000th. So that makes the maximum and minimum, and we can't control the tolerance for this part. It's off the shelf. It's coming. We're buying it, and this is we'll get something between 3/16 plus 1/10,000th and 3/16 plus 3/10,000th. So that's a maximum of 0.1878 inches and a minimum of 0.1876 inches. So if we look at the sheet again, the PDF, that will be in this row here. Now there's limits of interference, and we want to make sure we're inside these limits. So when we can either have 0 interference, where it's just perfectly touching, or half a thousandth of an inch interference. So the way he did it was to use the minimum as a 0 and do a bunch of stuff. What I find to be simplest is basically take your maximum the maximum that the shank can be, which is 0.1878, and subtract half a thousandth to get 0.1873. And so on the top, so I got to 0.1873 as that's the number that we're concerned with, and we will apply to the chart. And so since it's for a hole, we see that in this area, we have plus 3 10,000ths minus 0. So over here, I have the upper limit is 0.1876. That has nothing to do with 0.1876 being our previous minimum. It just happened to be that. That is the maximum it can be with the tolerances from that chart. And then 0.1873, which is the minimum, and that'll give us the correct limits of interference between these parts. So I think that's the main things he went over. Just hit me up on Teams or group me or whatever. If you have more questions, I'll do my best to explain.